Hello, this is Mr. Sumingo. I've graded all of your quizzes, and I wanted to go over a lot of the questions that many of you had or got incorrect in the last quiz. I know some of you have also messaged me or emailed me that some things that you understand, so as usual, next week you'll have another chance to make up or do one of the makeup or prove that you know one of the standards that you didn't make or didn't do well on last time. Again, don't get discouraged. You have until all semester to make these up, so I want to make sure that you all understand these. I think, again, I chose a lot of these topics because I feel like they'll be easy for you to understand even though I'm not there. So I'm going to start with, again, I'm going to skip over the ones that a majority of got right, but the ones where a lot of you got wrong, I'm going to go over those. First of all, derivatives the long way. This one should be easy for the fact that you should already know what the answer should be. So for example, for level 1, and this one that you see in front of you, the derivative of 5x is 5. In level 2, the derivative of negative 10x squared is negative 20x. And for level 3, you know that the derivative of this is 2x plus 1. The question is, how do I get there? If you forgot, again, the formula for the derivative of the long way is similar to slope. The formula is the limit as delta x goes to 0, again, as the slope goes to 0, of f of x plus delta x minus f of x, y2 minus y1, over x2 minus x1, which in this case we're going to call delta x. Okay. Then we're going to plug in x plus delta x. Remember, there's 3 pieces to this formula. The first piece is the easiest piece. Delta x will always stay delta x. The second piece, f of x, is just copying it from the problem. In this case, you get 5x. And then the hardest part is the part that people get confused about, this x plus delta x. All you do is put in x plus delta x everywhere you see x in the function. So this becomes 5x plus delta x. To save you on time, obviously what I'll do next is I'm going to distribute that 5. I'm going to get 5x plus a 5 delta x. My 5x, my 5x and my minus 5x will end up canceling, which gives me a 5 delta x over delta x. These delta x's cancel, so that's how you get 5. On the next one, so that you understand how to do this, again, I'll write down the formula, limit as x delta x goes to 0 of the slope formula, which is f of x plus delta x minus f of x over delta x. Again, I'm just going to plug it into the formula. There's 3 pieces. 2 of them are very easy. The delta x is very easy. And then f of x, again, I'm just going to copy from the problem. So minus a minus 10x squared. The first part, again, you're going to plug in x plus delta x into the formula, or into the function. So I was going to say minus 10x plus delta x squared. Instead of just negative 10x squared, it's negative 10x plus delta x squared. Now, you'll see that things don't cancel out yet. You'll notice that I have a 2 here, which means I'm going to have to FOIL. I'm going to get a negative 10 x squared plus 2x delta x plus delta x squared plus 10x squared over delta x. And again, to save on time, I'm going to show you what cancels out. This negative 10, I'm going to have to distribute to all of these. You're going to get a minus 10x squared and a plus 10x squared that's going to cancel. So what's going to leave you with is a minus 20x delta x and a minus 10 delta x squared all over delta x. Again, if you're doing this right, delta x should cancel for all from the top and from the bottom. So I'm going to cancel 1 here, and the 1 down here. So the whole problem is just going to be negative 20x minus 10 delta x. Remember, this whole problem was as delta x goes to 0. So remember, as delta x goes to 0. So when I plug in 0 here, the answer just becomes 20x, which again should be the problem. I'll save you doing level 3, but I think you get the point after you see these 2 examples that really just plug it into the formula and get the answer that you should already know what to do. You shouldn't be leaving these blank. Okay. Chain rule, I'd say 90% of the class got this right, so I'm not going to go over chain rule. If you have any questions about chain rule, you could ask me when I come back. Okay, implicit differentiation. First of all, level 3, there's a typo in here. Some people wrote their own problem, like they put a plus or minus, that's fine, but for now I'm going to cross this out. Sorry, there's 2 equal signs, so we shouldn't have done that. But you should be able to do 1 and 2. Implicit differentiation, if you remember, is doing the derivative when you have an x and a y. So I have both an x and a y in the problem. I need to derive it. Like I taught you, every time you see a y and you derive it, you have to add a y prime. So in this problem, you'll see that I have x to the third. That derivative is 3x squared. You have a y to the third. You already know it's 3y squared, but because again I'm deriving by two variables, I'm going to add a y prime. And then you know the derivative of y is 1, and then you have to add a y prime, so 1y prime. The goal of implicit differentiation then is to get the y prime by itself. So the first thing I'm going to do is add the 3y squared y prime to both sides. So do you see this is now moved to the right side? I just added it to the right side. Then I'm going to factor out a y prime, which gives me 1 plus 3y squared. And I'll divide both sides by 1 plus 3y squared. So your answer should be 1 plus 3y squared in the denominator equals y prime. That is how you do implicit differentiation. The second one should have been long because there's a product rule here in the middle. So to do this really quickly, I got a 2x. And then when I do my product rule, I have two terms. I have a minus 16x and I have a y. So I'm going to do product rule. Product rule says the derivative of the first one, which is minus 16, leave the second one alone. So minus 16y. Plus, leave the first one alone, which looks like this, negative 16x, times the derivative of the second one. The derivative of y is 1, but I have to add a y prime. So it looks like that. Plus y squared, you know, the derivative of y squared is 2y, and I have to add a y prime. And some of you made this, a lot of you made this mistake. I have to take the derivative of 1, in this case is 0. Okay, I know a lot of you, your only mistake was that you left that as 1. That has to be 0. I'm going to simplify this real quick. 2x minus 16y minus 16xy prime plus 2y y prime equals 0. Now the last piece, like we did in the last problem, is just get the y primes on one side, all the non-y primes on the other side, and get y prime by itself. So this left side, I'm going to leave the y primes alone and move over negative 2x and a 16y. So basically this, I just moved to the other side. Okay, or I subtracted or added it to both sides. Then I'm going to factor out a y prime. This gives me a negative 16x plus 2y. And then the very last step, what you're going to do, I'm out of space, is divide both sides by the parentheses. So this parentheses right here, you'll divide by both sides. So your answer should be y prime equals negative 2x plus 16y all over negative 16x plus 2y. Some of you factored out a 2, so you could simplify this into x plus 8y, but in any case, either one is correct answer. So that's how you do implicit differentiation. All you do is take the derivative, add a y prime every time you do a derivative of y, and then you'll get y prime by itself. That's implicit differentiation. Where a lot of people got stuck, trig derivatives. You're going to need to have a strong foundation and know and memorize all the rules for trig. Okay, I know I haven't been there, so I understand that you guys need some help with this, and I'll help you guys out when I get there. I apologize, level 1 was very difficult. First of all, I see this cosecant squared x squared. This can be rewritten as cosecant x squared, and that whole thing is being squared. So this is a chain rule type problem. I have the 2 power, I have cosecant, and I have x squared. So I have a 3-layer product rule problem. So what I'm going to do is I'm going to do the chain rule. The very first thing is the 2. I'll put the 2 out in front and leave the inside alone. And then it should be subtracting 1, so that's to the first power. Times the derivative of the inside. The derivative of cosecant is negative cosecant cotangent. Okay, again, it's things you're going to have to remember. Because I have an x squared, I'm going to have to leave the x squared, so times negative cosecant x squared cotangent x squared. So again, the derivative of cosecant is cosecant cotangent, and I have to leave the inside alone. Times the derivative of the inside of that, you know, the inside of this function is x squared, and that derivative is 2x. So you can leave it like that. If you want to make it nice and neat, it should be minus 4x. I have a cosecant x squared, and I have another cosecant x squared, so they're multiplied by each other. So I'm going to do cosecant squared x squared, and I have a cotangent x squared. Again, I apologize, that was a very difficult level 1, but that's how you do that problem. Next one, same thing. I got a chain rule. I got a 2 out there. The derivative of tangent, you should know, is secant squared. So the derivative of tangent is secant squared, just so you know. So let's do my chain rule. I got 2, leave the inside alone. And then this should be raised to the first power. Times the derivative of the inside. You should know the inside is a quotient rule, so now I got to do quotient rule to this thing. Okay. In quotient rule, I take the derivative of the numerator, secant squared x, leave the second part alone, which is 1 minus tan x. Okay. Minus, I'll leave the first one alone, which is tangent x. And then the derivative of the second one. The second one, the derivative is going to be a negative secant squared because derivative of 1 is 0, and the derivative of negative tangent is negative secant squared. All over the denominator squared, 1 minus tan x squared. So if anything, this should have been a level 1, and level 1 should have been level 2, but there you go. That's how you do that type of problem. And just so you see more practice, here's level 3. Okay, let me erase this real quick, or let me just move over to the side here. I've got tangents. Again, we already know what the derivative of tangent is. It's secant squared. The derivative of secant, if you may not know, is secant tangent. Okay, so the derivative of secant is secant tangent. This is all just a quotient rule. There's no chain rule. It's just straight quotient rule. So here we go. The derivative of the numerator, as I told you, secant. In this particular problem, they use theta. So secant theta, tangent theta. Leave the second one alone, so 1 plus tan theta. Minus, I'll leave the first one alone, secant theta, times the derivative of the denominator, and the derivative of the denominator is just going to be secant squared. All over my denominator squared. So even this was easier than level 1. But again, all kind of doable if you remember the rules for trig. Again, this is something you might have to refresh your memory on, and something you should have learned last year, the derivatives of trig functions. Okay, 2 more that I'm going to do for you, 2 stands I'm going to do for you. ln e derivatives. This one should be fairly easy compared to chain rule, compared to product rule, quotient rule. ln and e is very simple in terms of how the derivative looks like. You know the derivative of ln x is just 1 over x. So the ln of whatever you have is just 1 over it. Okay, you might have to do chain rule or something like that. E, you know the derivative of e to the x is just e to the x. If it's e to the 2x, by chain rule, it's going to be 2e to the 2x. Or basically anything up with that, anything up in the exponent with x is going to be like that. So if it's e to the negative 5x, it'll be negative 5e to the negative 5x. If it was e to the 10x, it'll be 10e to the 10x. That's all because of chain rule. That's how you do that. Okay, so just keep that in mind as I solve these problems. The derivative of ln is 1 over x, and the derivative of e is just e to the x. If by chance you have a function in the exponent, you just multiply or put in the coefficient the derivative. So let me erase this real quick, and let's solve these problems. So in this particular problem, I have a chain rule. Okay, I have something inside ln. So you already know the derivative of the outside function, the derivative of ln, is 1 over whatever you have on the inside. Then I have to multiply by the derivative of the inside. The inside, you notice, is a product rule. I have 3x times radical 3 plus x. So here we go. The derivative of the first one, which is 3, leave the second one alone. Plus, leave the first one alone, 3x. And then the derivative of radical 3 plus x, I'll just do a side calculation here. That's the same thing as 3 plus x to the half, which is the same thing, or when I take the derivative, is going to be half 3 plus x to the negative half. Times the derivative of the inside. The derivative of the inside is 1, so there's nothing really I have to multiply there. So I'm just going to put this right here. Half 3 plus x to the negative half. And if this is all as far as you got, I would take this answer. Okay. You can also simplify it, but again, I'm just looking that you know how to do ln and e. Second one, I have a product rule. I have 2 things multiplied, e to the negative 3x, and it's multiplied by sine 5x. So, derivative of the first one, again, the rules for e, so negative 3e to the negative 3x. Leave the second one alone. Okay, so far? plus, leave the first one alone, times the derivative of the second one. The second one is a chain rule. I have to do derivative of the outside times the derivative of the inside. The derivative of the outside function, derivative of sine, you should know is cosine 5x. And times the derivative of the inside, which in this case is times 5, and I'll put that here in the coefficient. So if this is as far as you got, I would take that. And the last one, the hardest one, this one doesn't have any product rule, so it should be relatively easy. The derivative of this first term right here, again, using the rules of e, should be pi e to the pi x. Okay. Minus, and then here I have a chain rule. I have e pi x inside. I have an pi x, which is inside e, which is inside ln. So I have a triple chain rule here. So the derivative of the outside function is ln, which is 1 over e pi x, times the derivative of the inside, which is again pi e to the pi x, like so. So that's how you do that chain rule. You could simplify it. This right here, I mean, if you stopped here, that's fine. You should know this up here, sorry, this down here and this up here will cancel. So the real simplified answer is going to be pi e to the pi x minus pi. So not too bad. And the last one, I made a mistake here because I put the same question twice. So if you did it once, I just gave you the credit for it. So I'm just going to do this one for you. I want to find the relative max and min. So I want to know what the critical numbers are, where is it increasing and decreasing, that whole thing. To do so, I have to take the derivative. The derivative will give me 4x to the third minus 2x. And because I'm looking for the critical numbers, I set this equal to 0. I factor this, which is 2x and x minus x squared minus 1. One of these has to equal 0. So this one has to be 0 to equal 0. And the second one, a lot of people had difficulty with. So if you couldn't do this in your head, you could also do this algebraically. X squared minus 1 has to equal 0. I could add 1 to both sides, and I take the square root of both sides. So x could equal plus or minus 1. So I have 3 critical numbers. Okay, I have 0, plus 1, and I have minus 1. Okay, so what I'm going to do is I'm going to put these all in a I'm going to put this all in a number line. Here's -1, here's 0, here's 1. Okay, so hopefully you're understanding so far, not too confused. Okay. Oh wait, this is where I made a mistake. I was wondering why. Sorry about that. Okay, when I factor out a 2x, this should be 2x squared right here. Sorry about that. So now, again, this is why people will get confused. I will set 2x squared minus 1 equal to 0. I'm going to add 1 and divide by 2. So I get x squared equals half. And if I square root both sides, I get x equals the plus or minus square root of 1/2. Okay? Or if you do this, you should also know that's the same thing as the plus or minus the square root of 2 over 2. So on my number line, I'm going to get a 0. I'm going to get negative radical 2 over 2. And I'm going to get positive radical 2 over 2. If you use a calculator, radical 2 over 2 is slightly bigger than 0.5. Okay? So the numbers I want to test 0.5, negative 0.5. I want to test -1. I'm going to test 1. And if you're confused, you can plug this into a calculator and see what decimal you get. Okay. Now, to figure out if this is increasing and decreasing, I plug this into my derivative. Okay. If I plug it into 2x, I get a minus. If I plug it into the parentheses, if I plug in -1, I'm going to get a positive number. So this whole thing is this whole thing is negative. Sorry. So if I plug in a -1, I get 2 times 1 minus 1, which is where I get that positive. If I test negative half, I get a negative when I plug it into 2x. If you need to see that, I'm plugging it into here, and I'm plugging it into here. If I plug in -1/2 into here, -1/2 squared is 1/4. 1/4 times 2 is 1/2. 1/2 minus 1 is negative. So negative times a negative is positive. If I try positive half, I get a positive here. Half squared is 1/4. Half minus 1, I still get a negative. This whole thing becomes negative. And lastly, if I plug in 1, I get positive and positive. This whole thing is positive. Okay. So what does this tell me? This tells me I am increasing. Okay, I am increasing from negative radical 2 over 2 to 0, and from radical 2 over 2 to infinity. Okay. This tells me I am decreasing from negative infinity to negative radical 2 over 2, and from 0 to radical 2 over 2. And all I'm doing is just reading these intervals to where it's positive and negative. And then to find the relative max and min, I notice I have my three numbers. Remember, my three numbers are here, here, and here. They have to be either maxes or mins, or neither. This one, I'm going from negative to positive. Negative, positive looks like this. I have a min here. At 0, I go from positive to negative, from a slope positive to a slope negative. That means I have a max. And then radical 2 over 2, I go from negative to positive again. That's also a min. So you should say I have a max at 0, and I have a min at negative radical 2 over 2 and positive radical 2 over 2. So those are all the ones I wanted to go over in the quiz. Today in class, all I want you to do is just go through these, watch this video. I'm also giving you some time in class to rearrange your things in terms of you should have notes for all the videos. You should have videos for each of the classworks. I know some of you had trouble uploading, but it should still be on your iPad. If you have any questions or any concerns or any difficulties, please feel free to message me or to email me. So thank you for watching, and hope you have a great day.